dear, it's very sour.
Say again.
It's very sour.
That must be acidic. Now, the word acidic comes from the Latin word acid, which means sour.
All along I thought acid was harmful.
Yes, but there are some acids which are harmless and edible. But before I dwell on the subject in detail, I want you to try this edible mixture.
Not me. Once bitten, twice shy.
I promise you it's not going to be sour.
Okay, I'll take your word for it. Yuck, it's worse than sour oranges.
Sorry about that. What you have tasted was milk of magnesia. It's a solution from a base.
What is a base?
That's what we are going to find out in today's program. Acid, base, and... what's this?
Salt. I don't have to taste it, but I know it's saltish.
Boys and girls, in today's program, Jennifer and I will be discussing acids, bases, and salts. These are common compounds which we use in everyday life. Some acids are harmless and edible. They are citric acid, which can be found in lemons, limes, and oranges. Grapes and baking powder contain tartaric acid. Apples contain malic acid. Tea contains tannic acid, and lactic acid is present in our milk or yogurt, as it is commonly known. These acids, which are obtained from living things, are called organic acids. Another class of acids comes from rocks or minerals. They are known as mineral or inorganic acids. They are hydrochloric acid, sulfuric acid, and nitric acid. These acids are very harmful, corrosive, and can cause burns. Let's look at the next group of compounds called bases. This is a metal called calcium. Heat the calcium and lower it into a gas jar of oxygen. When the metal calcium burns in oxygen, it becomes calcium oxide, which is an example of a basic oxide. When you dissolve calcium oxide in water, an alkali called calcium hydroxide is formed. Common examples of alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide, and ammonium hydroxide. The last group of compounds that we will be looking at will be salts.
I know that salts are found in abundance in nature. For example, in seawater.
Yes, seawater contains salts like sodium chloride and magnesium chloride. Other than the sea, chalk cliffs are made up of salt like calcium carbonate.
Uncle Donald, what is the scientific name for the table salt that we eat?
Table salt, or common salt, is known as sodium chloride. Other examples of salts include sodium nitrate, sodium sulfate, sodium carbonate, potassium chloride, and so on.
How do we prepare a soluble salt like sodium chloride?
Well, it's easy. Give me an example of a base and an inorganic acid you have learned.
Sodium hydroxide and hydrochloric acid.
When you mix both solutions, the base and acid, you get salt and water. That is, sodium hydroxide and hydrochloric acid will give you sodium chloride and water. Evaporate the sodium chloride solution and you get sodium chloride crystals. Try this. Does it taste like salt?
Yes, it is salt. What are the uses of salt?
Salt has many uses. For example, fused calcium chloride is used as a drying agent in desiccators. It absorbs moisture and prevents your apparatus from becoming rusty in a desiccator. Potassium nitrate is used in making matches and gunpowder. It is also used as soil fertilizers. Sodium chloride is used for preserving foods and glazing pottery. There are many other uses of salts which are listed in page 66 of your textbook. Having learnt so much on salt, let's find out more about acids and bases. Most solutions of an acid, a base, or a salt are colorless.
So, how can you tell whether a given solution is an acid or a base?
To be able to identify the solution, you must examine its properties. For example, you have learnt that an acid is sour and an alkali is bitter. However, it is not safe to taste unknown solutions because they could be harmful. Dip your fingers in this solution of sodium hydroxide. Rub your fingers. How do you feel?
It has a soapy feel.
Do you know why?
No.
It is because the small amount of fat in your skin is changed to soap by the sodium hydroxide. Another way to distinguish an acid from a base is to use indicators. They are litmus paper, methyl orange, and phenolphthalein. The 4 small beakers contain dilute sulfuric acid. Let's see the changes in color to these indicators.
Blue litmus paper turns red. Red litmus paper remains unchanged. Methyl orange becomes red. The color of phenolphthalein remains unchanged.
Let's do the same with sodium hydroxide solution.
Blue litmus paper remains unchanged. red litmus paper turns blue. Methyl orange becomes yellow. Phenolphthalein becomes red. Now I know that it is easier to distinguish an acid from an alkali by using an indicator.
We can also measure how acidic or alkaline a substance is by using a scale of numbers called the pH scale. The numbers range from 0 for very acidic to 14 for very alkaline. A neutral solution, for example, pure water, has a pH value of 7. An indicator, like litmus or methyl orange, will change color at a fixed value of pH. This value is different for different indicators. This chart showing the pH scale is based on the use of an indicator called UI, or universal indicator, which is a mixture of indicators.
I would like to find out the pH value of this fresh milk.
Add a few drops of universal indicator into this test tube of fresh milk. What's the change in color?
It's yellow.
Yes, it's a weak acid solution with a pH value of 6. Now, do the same for seawater. Now, what's the change in color?
It's greenish blue.
Match it with the pH chart. Yes, it's a weak alkali with a pH value of 9. Boys and girls, it's very useful for us to know the pH value of a solution. Farmers and gardeners use it to test the soil when growing plants. It is also used in the water treatment plant and in other industries in quality control. Now, let's look at the other basic properties of acids. Acid contains hydrogen. For example, when hydrochloric acid reacts with a common metal, zinc, hydrogen is evolved. This gas can be tested by using a lighted wooden splinter. A pop sound is heard. Another property of acid is it gives off carbon dioxide when it reacts with a carbonate. Do you remember the test for carbon dioxide?
Yes, it turns lime water chalky. What gas is evolved when an alkali reacts with an ammonium salt?
Let's take the salt ammonium chloride. When you add sodium hydroxide, you get a gas called ammonia. Ammonia, being an alkaline gas, turns a red litmus blue.
Uncle Donald, we have been learning about acids and bases. I wonder how important they are in our lives.
Well, let me touch on acids first. There are 1,001 uses. Let me name a few. Tartaric acid is used in making baking powder, which is used for baking cakes. Soft drinks and health salts also contain tartaric acid. Vinegar is acetic acid and is also used to preserve food. Dyeing of textiles and making of paints need acetic acid. The inorganic acids are used extensively in industries to make chemicals. Hydrochloric acid is used in a chemical to remove rust. Sulfuric acid is used as electrolyte in a car battery. It is also used in soda acid fire extinguishers. Nitric acid is used for making fertilizers and explosives. Let's see the uses of alkalis. Calcium hydroxide is used in making mortar, cement, and plaster. Magnesium hydroxide is used in making toothpastes and laxatives. Ammonia solution is used as a detergent and a bleach. Sodium hydroxide is used in making plastic, petroleum, refining, and the making of soap, which we shall see on film. This is the mixture tank. Salt, sodium hydroxide, and fats like palm oil, coconut oil, and tallow oil are the main ingredients used in soap making. The mixture is heated by steam. Every 4 hours, the impurities are drained out. Fresh water, salt, and sodium hydroxide are replenished 6 times every 4 hours. Finally, you get the soap solution, which requires another 48 hours to settle. From here, it is drained into a holding tank where additional chemicals and coloring are added. Then, the solution is filtered. After filtering, the moisture in the solution is evaporated and the fragrance is added to the soap. The soap is broken up into smaller pieces to speed up the evaporation process and even mixing of the fragrance. The soap is compressed into a long bar. It is cut to size and cooled to harden. After stamping, they are sent for wrapping. Here are some samples of soap manufactured in the factory.
Little did I realize that acids, bases, and salts were used extensively in our lives.
Yes, boys and girls, you have seen only some of the practical applications of acids, bases, and salts in everyday life. The next time you come across a substance, can you identify it through the properties of acids, bases, and salts that you have learned?